Okay, hi everybody. So we're going to take a look at these two expressions right here, okay, which is C union B, so set C union set B minus A, or, okay, and C intersection B minus A. Now, we've gone over union and intersection before, so really what this is about here is set subtraction, okay? And as soon as we understand what set subtraction looks like, then these two are going to fall into place relatively easy. So let's just take a quick look at it. Let's say I've got the expression A minus B. What I intend by that, okay, and we're going to look at a Venn diagram here. Here's set A, here's set B. What I intend by that is this right here. I'm going to shade that in. Is this little bit right here. It's the part of A that doesn't overlap with B. Okay, so we're taking away that piece right there. Another way that you might look at it here is it's going to be A, well here I'll do it over here. It's going to be A intersection, not B. Now let's just take a look at what that means here. So here's A again and here's B. So A is going to be this set right here. Okay, not B. It's going to be everything outside of B. So I'm going to shade that in this way. Okay, and where those two intersect, which is going to be this part right here, this cookie with a bite out of it piece right there. So that's what we're talking about when we're talking about set subtraction. So now we should be able to go back up to these expressions here and make a little bit more sense of them. So let's take a look at C union B minus A. And again, we'll use a Venn diagram to help us illustrate this. So here's A, here's B, here's C. So we'll start with what's in the parentheses there first, C union B. And C union B is going to be everything that's C and everything that's B together here. So we're going to shade, okay, all of that. Now what we want to do is we want to subtract A from that. So what that means is we're actually interested in where C union B intersects not A. Okay, those are going to be equivalent here. So not A, and I'm going to use that with horizontal lines here. So not A is going to look like this. Okay, going across, going across. So where do those all intersect? Well, they're going to intersect here. Okay, in that. So we're going to use the part of B that's not in A together with the part of C that's not in A. And so that's what C union B minus A would look like. Now let's take a look at the other expression. C intersection B minus A. So we'll throw that down. C intersection, okay, B minus A. Now, again, our three sets. And let's do what's in parentheses first. So we've got our A, our B, and our C. So B minus A is going to be everything in B that's not in A. Now, hopefully that makes a little bit more sense here, and I'll kind of just run to that. So B minus A is going to be this part right here that's in B that's not in A. And so for this first little bit here, B minus A, I don't even care about C. I'm not even worried about the fact that there's another set there. That's irrelevant for the time being. Okay, so B minus A is going to be this little piece right there. Now what I'm interested in is C intersection that. So let's look at set C. Set C is going to be this right here. And I'm looking at the piece where they both overlap together. And that's going to be this little section right here. Okay? And so there you go. That's what's intended by C intersection B minus A. I hope that makes sense.